Okay, hi, and let's read more osteoarthritis. Unhealthy diets cause hormonal imbalance. Fat is an important hormone producing organ. The organs in our body that produce hormones are called endocrine organs. Recent research reveals that fat is an important endocrine organ. Oh, weird. Hormones regulate our body's chemical balance called homeostasis. In the case of obesity, the wrong hormones are produced by the fat around the waist. This inflammatory fat contributes to the increase of inflammation throughout the body. Fat normally produces hormones called adipocytokines. Two important adipocytokines are leptin and adiponectin. These fat-derived cytokine hormones control fat and sugar metabolism in the body. Inflamed fat found in joints produces leptin and adiponectin, which play an important role in stimulating cartilage cells to produce cartilage-degrading enzymes and inflammatory compounds, which lead to cartilage breakdown in osteoarthritis. Okay, page 108. The role of leptin in inflammation and obesity. Leptin is a hormone produced by fat cells. The levels of leptin and the inflammatory compounds IL-1 and TNF-alpha are increased in obese people. Leptin interacts with cells to activate certain genes that have important regulatory effects on energy production. Let's see. Okay, I have an idea. Okay, that actually helps. Okay. Leptin interacts with cells to activate certain genes that have important regulatory effects on energy production, our body's inflammation state, and the development of insulin resistance. A chemical compound called SOC3 SOC3, which I will discuss in more detail in chapter 12, is important in the signaling pathways of leptin. Leptin acts through brain receptors in the hypothalamus to cause us to stop eating when we have consumed enough calories. Yes. The hypothalamus has a number of regulatory centers that control functions in the body, such as breathing and hunger, that are not under our conscious control. The important function of controlling hunger is regulated well when leptin functions normally. But when leptin is increased, a state of leptin resistance develops, and the hypothalamus does not respond appropriately to its signals. As a result, we continue to eat even when our body does not need the excess calories. Leptin, oh my gosh. Excuse me. Okay. Leptin is critical to determining how fat is processed in the body and how much inflammation is present in our bodies. Genetic mutations have been found in the gene that codes for the leptin hormone that leads to the development of obesity, insulin resistance, and eventually type 2 diabetes. Leptin increases inflammation by increasing the production of inflammatory compounds by white blood cells. Leptin resistance. In people who are obese, leptin and insulin hormones are dysfunctional, making the body unable to properly hear the signals conveyed by these hormones. Obesity leads to increasing circulating levels of leptin. A state of leptin resistance develops in obese people that, like insulin resistance, results in cells not responding to the messages of leptin. Studies have shown that people with metabolic syndrome have insulin resistance with elevated insulin blood levels. This elevated insulin leads to increased blood leptin into leptin resistance. Leptin stimulates production of inflammation cytokines and nitric oxide. Leptin is overproduced by the plump fat cells in people with obesity. It is also overproduced in arthritic cartilage cells. That's not fair. Okay. Increased leptin levels trigger an increase in the production of the inflammatory compound nitric oxide. Nitric oxide is important in activating the genes in cartilage cells that produce inflammatory compounds and in also activating suicide genes, in quotation marks, that lead to cartilage cell death. Leptin also teams up with another cartilage villain, IL-1, to increase the production of nitric oxide. As discussed earlier, IL-1 is an important cytokine produced by osteoarthritic cartilage cells and inflamed fat around the joints. Both IL-1 and nitric oxide activate genes in cartilage that increase the production of the cartilage degrading MMPs. IL-1 stimulates another inflammatory substance, oncostatin M, to further increase MMP, and another cartilage degrading enzyme, ADAMTS4. ADAMTS4. Thus, a cycle of increasing cartilage destruction is generated. Leptin levels are elevated in osteoarthritis and obesity. Research has shown that cartilage cells contain the leptin receptor known as OBR. In the absence of leptin resistance, leptin stimulates cartilage cells to increase their growth and the production of the three-dimensional collagen structure that gives cartilage its strength and resiliency. When leptin is measured in the synovial fluid in cartilage taken from osteoarthritic patients, it is found to be elevated. Obese patients with osteoarthritis have either leptin levels in their joints have higher leptin levels in their joints than non-obese osteoarthritic patients. Research has found that the more obese a person with osteoarthritis is, the higher the level of leptin seen in their synovial joint fluid. Leptin is not found in the joint fluid of normal non-arthritic knees and is only minimally produced in normal cartilage. Heavier people who are also osteoarthritic have increased leptin in both their knees and the arthritic bone spurs that are often seen accompanying osteoarthritis. Bone spurs are excess bone that develops in the joint adjacent to areas in which the cartilage cap that covers the bone has been worn down by osteoarthritis. Osteoarthritis is more destructive in people with increased joint leptin levels. On the other hand, normal leptin levels, as well as normally functioning leptin without leptin resistance, have beneficial effects on cartilage, including increased production of IGF-1 and TGF-beta1, which promote the proper building and maintenance of cartilage. An increase in leptin levels stimulates the production of inflammatory compounds. It is also known that women have higher circulating leptin levels than men do, and this may be a factor as to the reason obese women develop earlier onset and more aggressive damage to their knees from osteoarthritis than obese men do. Adiponectin plays a role in osteoarthritis. Adiponectin is a fat-derived hormone found in lower levels in obese than non-obese people. Lowered adiponectin in obesity is associated with the development of insulin resistance and metabolic syndrome. Researchers have shown that fat cells present in joints produce adiponectin. In osteoarthritic joints, adiponectin has been shown to have inflammatory effects by increasing the production of IL-6 and stimulating the production of cartilage-degrading MMPs. The gene that codes for adiponectin has been isolated and has been shown to be very active in joints of osteoarthritic people. Adiponectin's role is currently not completely clear and is being explored in attempts to determine how it is involved in cartilage breakdown. Figure 10.1, detrimental effects of increased leptin and leptin resistance on joint cartilage. Obesity leads to increased leptin production and leptin resistance. Leptin increases production of inflammatory compounds, cytokines, and NO. Leptin is increased in osteoarthritic joints. Obese osteoarthritic people have more leptin in their joints than non-obese osteoarthritic people. Leptin links the obesity epidemic to the development of osteoarthritis. Leptin and IL-1 increase NO and cartilage breakdown. Obese women have elevated leptin levels and a predisposition to early development of osteoarthritis. The proper functioning of insulin fights inflammation in the body. Insulin, when functioning normally and in the proper blood levels, has beneficial anti-inflammatory and antioxidant properties. Properly functioning insulin suppresses the important inflammatory message relay station NFKB, which turns on harmful genes in cartilage cells. Insulin also acts to decrease the formation of oxygen-free radicals, which harm cartilage, and also decreases the production of inflammatory compounds IL-6 and TNF-alpha. Ooh, cool. Inflammatory cytokines, okay, figure 10.1. Inflammatory cytokines produced in knee fat. Knee joint, kneecap, patella, femur is the upper bone, the cartilage in between, the tibias below, patellar tendon underneath the kneecap. That's probably what I've torn. Okay, inflamed fat pad in knee joint produces inflammatory cytokines, leptin, and adiponectin. Okay, and here's this cute little diagram. This is Osteoarthritis, Preventing and Healing Without Drugs by Peter Bales. Page 12. Insulin resistance skyrockets the production of free radicals. Insulin resistance increases inflammation in our bodies, leading to the development of metabolic syndrome. It also increases the production of oxygen-free radicals, leading to increased oxidative stress. Oxygen-free radicals attack the cell membrane and cause its components to become rancid or oxidized. The results in leakage of the membrane and toxin accumulation in cells. Free radicals also activate NFKB, triggering inflammation. Excess blood sugar itself directly stimulates NFKB and turns on inflammatory genes in cells. It also stimulates another important cell enzyme, NADPH oxidase, which forms more free radicals. Increased inflammation and insulin resistance lead to hormonal imbalances. People with increased levels of insulin and sugar in their blood have more inflammation and also have higher production of cortisol. Cortisol is the hormone produced by the adrenal glands, which sit on top of the kidneys and is involved in the fight or flight response. It is a stress hormone that is increased in situations of physical or emotional stress. Chronic elevation of stress is harmful to the body. In a state of constant stress and inflammation, the excess production of cortisol leads to muscle breakdown and increased blood sugar levels. Excess cortisol also increases insulin levels, which leads to a vicious cycle of increase in the fat around the waist. Other harmful effects include an increase in production of arachidonic acid and a decrease in testosterone. If stress is not controlled, a condition referred to as adrenal burnout eventually develops, resulting in the inability of the adrenal gland to produce its hormones at appropriate levels. The roles of SNPs and genetic individuality. The new research in genetics has identified small changes in the genes, SNPs, of important inflammatory compounds that predispose individuals with a higher SNP to increased inflammation and damage. This highlights the genetic individuality among different people and their different responses to the environment and what they eat. Figure 10.3, detrimental effects of insulin resistance. Increased inflammation in the body, hormonal imbalances, cartilage breakdown in joints, development of obesity, leptin resistance, increased formation of damaging free radicals in our joints, development of metabolic syndrome. Genetic studies have shown that the IL-6 gene contains an SNP that predisposes people possessing it to a much higher incidence of insulin resistance. The fat-produced adiponectin hormone is coded by a gene that has an SNP known as 276GT SNP. Carriers of this particular SNP have a higher propensity of developing oxidative stress in their bodies. Leptin, another fat-producing hormone, is coded by the OB gene. Research has shown that mutations in the gene that codes for leptin cause obesity and high blood pressure in both humans and animals. Obesity predisposes women to increased leptin levels and to osteoarthritis. New scientific evidence, as well as my personal experience of patients being seen for osteoarthritis, suggests that osteoarthritis is more common in women than men. Studies have shown that obese women have a higher incidence than obese men of knee osteoarthritis development and progression at a younger age. Leptin has been shown by researchers to be actively involved in osteoarthritic joint damage. And women have higher leptin levels than men. There seems to be a correlation of obese women, increased leptin levels, and the propensity to develop earlier onset osteoarthritis. The Framingham study, a large study initiated in 1948 by the National Institutes of Health to study the causes of heart disease and stroke, has followed large groups of patients, including families with grandparents, parents, and children, over time to determine how risk factors such as obesity, hypertension, smoking, and genetics play a role in the development of heart disease. Showed that in overweight females, losing only 11 pounds decreased the risk of symptomatic knee osteoarthritis by 50%. Furthermore, hand osteoarthritis, which involves non-weight-bearing joints, positively correlates with obesity. Hand joints are not subjected to the same mechanical stresses as knees and hips, so their association with obesity is the result of chemical and hormonal causes, as opposed to excessive weight mechanically causing the breakdown of joints. These findings support the theory that osteoarthritis is a disorder contributed by metabolic dysfunction in the body. Estrogen receptors, menopause, and osteoarthritis. The female hormone estrogen is an important regulator of cartilage cells, and women have a higher incidence of osteoarthritis compared to men. Cartilage cells have estrogen receptors on their surfaces, and female cartilage cells, more than male cartilage cells, when stimulated by estrogen, increase the production of cartilage repair enzymes and the components of the cartilage framework. Estrogen has other beneficial effects in the body by stimulating the burning of fats, activating the anti-inflammatory message relay station PPAR delta, and preventing the formation of fat. Menopause results in decreased levels of estrogen, which can be detrimental to joint cartilage. Women with hormonal imbalances caused by obesity and increased blood sugar levels are especially at risk for developing osteoarthritis. Results from the Framingham study have shown that women with higher bone mineral density, BMD, and thus stronger bones have decreased risk of progression of their osteoarthritis. Menopause, with its relative estrogen deficiency and increased fat formation, results in weakening of the bones of women and also increased risk of developing osteoarthritis and other metabolic diseases. It is important to note that increased fat decreases the strength of bone. While it is true that a higher body mass is correlated with stronger bones, when the fat percentage of total body mass is looked at, it correlates with the weakening of bones. Thus, being overweight is both detrimental to bone and cartilage. Conclusions. The hormonal and metabolic status of our bodies has an important effect on the development of osteoarthritis. The maintenance of optimum insulin levels in the bloodstream and optimum insulin functioning are important in combating cartilage destruction in osteoarthritis. Poor nutrition generates a cycle of hormone imbalance that negatively affects the whole body. Middle-aged women who are also obese have a high risk of developing progressive knee osteoarthritis. Obese women have increased leptin levels, decreased estrogen, and metabolically active obese fat cells, all of which interact to increase the inflammation in their bodies and lead to osteoarthritic cartilage breakdown. Estrogen is an important regulator of the cartilage cells, and its decrease in menopause predisposes to osteoarthritis. Osteoarthritis changes the chemical activity of cartilage cells by turning on genes that code for inflammatory compounds and increases production of cartilage degrading MMPs. Obesity is related to osteoarthritis development through high leptin levels and leptin resistance. Leptin resistance, combined with increased leptin levels in the blood and in the joints, is associated with greater cartilage destruction in osteoarthritic joints. Obese people with insulin resistance and metabolic syndrome also have leptin resistance. The detrimental hormonal effects of leptin resistance occur in obesity, prediabetes, and osteoarthritis. They provide a common link connecting the obesity epidemic with prediabetes and osteoarthritis. Leptin is a key regulator of cartilage cell function and activity. Leptin resistance and increased leptin production are important factors in the progression of osteoarthritis. Leptin activates white blood cells to produce inflammatory products, stimulates the production of nitric oxide, increases inflammatory cytokine production by cartilage cells, and acts to activate the immune system. The actions increase cartilage destruction in osteoarthritis. Leptin is produced excessively in people with metabolic syndrome and obesity. Leptin forms an important bridge linking obesity, metabolic syndrome, poor nutrition, and the development of osteoarthritis. SNPs in the OB gene coding for leptin, adiponectin, and IL-6 predispose certain people to increased oxidative stress, insulin resistance, and the development of osteoarthritis. Inflammatory diets high in sugar and saturated and trans fats lead to insulin and leptin resistance. These events trigger cartilage destruction in the joints of susceptible people by interfering with the normal cartilage repair and maintenance system. Okay. I'll come back in a moment for chapter 11.